Started on motion and forces. So I want you to click on the motion and forces packet. What you're going to do, it's going to come up, and we've got this on paper. If you'd like to print it out and work on it on paper and then attach pictures as you go, that is fine. All right, but you're going to hit open with DocHub. This is going to allow you to edit the assignment and change things based on your answers. Okay, so when you hit edit with DocHub, you've got your cover sheet, you've got a blank page, and then we start with page 1. You'll notice the page numbers are at the bottom. Now, we are going to complete pages 1 and 2 after we've done the notes on page 3. So the notes on page 3 have a PowerPoint that goes with them. The first thing you need to do is watch the YouTube video that's attached to the assignment for today, and it's called Distance versus Displacement. When you watch that, it's going to talk about the difference between distance versus displacement. And then we're going to complete the notes. You can use your text box right here to add text. And it says, how do we know when something has moved if we don't actually see it moved? So we need to know, how do we know if something has moved if we don't actually see it moved? So I'm going to look right here at my PowerPoint, and we're going to have some answers here. So the first thing it says is a mail truck. Okay, so let's look at this. How do we know that something has moved when we don't see it? If you see a mail truck outside your house and then you look outside 10 minutes from that time and it's somewhere else, you know that it's moved because we have a reference point, something that we use to determine the position of. If your friend is standing next to you and they're standing next to someone else, you are the reference point. They are no longer where they were. And motion occurs when an object changes its position relative to a reference point. So you need a reference point. And movement occurs when an object changes its position relative to a reference point. So we have distance versus displacement. If you go to your notes right here, distance is how far you've gone. If you run 5 miles, you've ran 5 miles. If you run 5 more miles, then you've run 10 miles. It's measured in meters or kilometers. So distance is how far we've moved, and it's measured in meters or kilometers. Be sure you fill that in. Displacement is the distance and direction of an object's change in position from the starting point. So displacement is the distance and direction of an object's change in position from the starting point. Now, displacement does not equal the distance traveled. So let's just say this. Displacement is how far you are from where you started. If you leave your front door and you run 5 miles, your distance traveled has been 5 miles. But if you end up right back on your doorstep, you are 0 miles from where you started. Your displacement will be 0 because you are the same place you started. So let's look at this football field. If we go 10 yards and then back 10 yards, our distance is 20 yards. But if we are right where we started from, our displacement is 0. Let's say we go 10 yards and then we come back 5. Our distance is 15 yards and our displacement is 5. The reason it's 5 is we are now 5 yards from where we started. If we go the whole length of the field, we have traveled 100 yards and our displacement is 100 yards. Why? Because we are 100 yards from where we started. All right? So if you look back at your notes, we're going to calculate speed now, and there's a specific way we calculate it. So it says speed is the distance an object travels per time. Okay, so we are going to calculate this using, it says distance. Real quick, let's look at this example. From A to B, our distance is 4 meters. From B to C is 3 meters. And therefore, if we walk from A to B and B to C, we've walked 7 meters. Okay, displacement is between the points. And so, like, if we walk 4 meters and then 3 meters and we're at C, we are 5 meters from where we started, but we walked 7 meters. Okay, so speed is the distance an object travels per unit time. So the way I want you to look at speed is we are going to use a triangle. Okay, and triangles make this very, very easy for us to calculate. So if we look at our triangle, we are going to use speed equals distance divided by time. We're going to draw a line through the middle and a line at the bottom. If we have a number above the line and below the line, we divide. If we have a number on either side of the line, we multiply. Okay, So let's say I am looking at my example. A car is traveling at a constant speed, covers a distance of 750 meters in 25 seconds. So for our triangle, we will always have it set up like this. Distance divided by time, remember, our divided distance divided by time, be sure you have this in your notes, equals our speed. So we can always put it in our triangle. So let's go ahead and set up our triangle. Okay, and you have a distance of 750 meters. So our distance is 750 meters. And our time is 25 seconds. And what do we do when one number is on top of the other? We divide. So if you take 750 and you divide it by 25, you are going to get an answer of 30 meters per second. That was your speed. So your speed was 30 meters per second. Okay, so that will go in your notes. Okay, so be sure you have that and be sure you have it correct. So when we look at the next part, we're going to practice. Okay, so you're going to go to your notes and you are going to practice using these problems right here. Okay, so the way I want you to set this up is you are going to look at problems 1 through 4. So we're going to write 1, 2, 3, 4. And we're going to use this triangle method for the rest of the year, so be sure you're using it. We're going to draw our triangle for each one. And remember, our triangle had speed equals distance divided by time. So draw your triangle for each one. And remember what goes in each spot because you can't get it mixed up. All right, a passenger elevator travels from the first floor to the 60th floor, a distance of 210 meters in 35 seconds. So distance goes on top, 210 meters, and then time goes on the bottom, 35 seconds. Now I can go through and set up each one. Constant speed, this one tells me the speed is 40 kilometers per hour. That's going to go in my bottom left, 40 kilometers per hour. How long does it take to go 10 kilometers? That means the distance is 10 kilometers. Okay, 3, how far does a car travel in 0.75 hours? Hours is my time, so I'm going to write 0.75 hours. And a constant speed of 88 kilometers per hour. So I'm going to write 88 kilometers per hour. And then lastly, number 4. A runner is running a constant speed of 5 meters per second. How far does he travel in 10 minutes? Now this is in seconds. So if we want 10 minutes, we need to do 10 times 60 seconds to get 600 seconds. Okay, so remember, if you have one number on top of the other, like in number 1, we would do 210 divided by 35, and our speed would equal 6 meters per second. For number 2, we have one number on top of the other, so we divide 10 divided by 40 equals a time of 0.25, and hours is our time, hours. And then if we look at number 3, we have one number beside the number. Remember, if you have one number beside the number, you are going to multiply. So 88 times 0.75 equals 66, and that is going to be our distance, so 66 kilometers. And then on the right, we have a number next to another, so we are going to multiply. 5 times 600 equals a distance of 3,000 meters. All right, so that is how you do those. Now we are going to use this to go back and do pages 1 and 2. Okay, so you are going to go back and do pages 1 and 2. All right, so let's look at pages 1 and 2. We're going to go back up. Okay, now on page 1, you are going to use these words in the blank and put them in each box. You can type them in there. And then I want what you think here. Okay, we haven't gone over this. I want what you think. And then right here, you are going to use your triangle and your knowledge of distance versus displacement to answer these questions. If she runs 200 meters west, remember, distance is how far you traveled, displacement is how far you are from the starting point. So a sprinter runs 200 meters west, north, south, east, west. Yep. 200 meters west, and then 100 meters back east. Okay, so her displacement, how far she is from where she started, she's 100 meters to the left of where she started. Speed can be calculated distance divided by time. The speed of a motorcycle at a particular moment is its instantaneous speed. Okay, Earth's plates move only a few centimeters per year. If they moved meters, we'd be in big trouble. 2 cars are each traveling at 72 kilometers per hour. One is traveling northeast and the other is traveling south. So they have the same speed but different direction, and we'll learn tomorrow that different direction would be velocity. Okay, so now we're going to look at the graph below and answer the questions. Okay, so look at this graph and you're going to answer. It says Ruth stops for 10 minutes to speak to her friend. So if she stopped, her distance is not increasing. So B would be that. She walks at a constant speed for 80 minutes. Okay, now where would you see her walking at a constant speed for 80 minutes? All right, think about that. I'm sorry, 80 meters per minute. So you may have to do distance divided by time. And then she jogs 600 meters in 5 minutes. Well, the only place I see a 5-minute increment is C. And you can tell she goes from 800 to 1400, which is 600 meters. So go ahead and fill that out. When you are done, you are going to click on this download and export button right here. Okay. Then you are going to click Google Drive. You're going to hit export to Drive and make sure all this is selected and you will be done. All right. So have an awesome day.